everyone. I am Dr. Jong Siat Lim from Faculty of Electrical and Electronic Engineering, University Tun Hossain On, Malaysia. Welcome back to ODE class. In this session, I will share with you a topic on Laplace transform. The learning outcome of this video is you will learn to solve ordinary differential equation using Laplace transform of special function, unit step function. Laplace transform of special function consists of unit step function and direct delta function, or we call it as impulse function.
Unit step function, also known as Heaviside unit step function, named after its founder and English engineer Oliver Heaviside. The notation of unit step function is ht minus a, where when t more than 0 or less than a, the amplitude is 0, and when t more than a, the amplitude is 1. Where a indicates the value of t at which the function changes from a value 0 to a value 1. Graphically, the unit step function can be shown in the figure on your right. From the graph, we know that the unit step function ht minus a has a value of t, which is changed from 0 to 1 at t equal to a. This type of function is very important in the field of electrical engineering, which involve on and off system.
Now, let's look at the example. Sketch the graph of ht. Ht is the amplitude is 1. Okay, from t is from 0 to infinity. This is to infinity. Okay, amplitude is 1. And this is 0 and this is t, where the graph this is y. Whereas for ht minus 4, okay, the graph is from t equal to 4 to infinity, and amplitude is still remain to 1. Okay, so this 4 here is referred to the t, is the time t. Okay, let's say if t equal to 5 means that the time is starting from, the t is from 5 to infinity. Whereas the amplitude is referred to the front. Let's say now is a 1 hash, so amplitude is 1. Let's say the example is 2 hash, so it's referred to amplitude 2. For this question, 2 is referred to amplitude, whereas 4 is referred to the time, where time equal to 4. So when you plot the graph, okay, x-axis is t, y-axis is y. So when t equal to 4, you can plot the 4 here with the amplitude 2. Okay, this one is 2, so amplitude 2, you can plot from t equal to 4 to infinity. To sketch the graph of t power of 3, first of all, you need to know what is the value for t power of 3. So let's say I draw the graph with starting from t equal to -1. -1 power of 3, I get -1. And then -2 power of 3, I get -8. And then I have, let's say I have -3 power of 3, I have -27. For positive value, I have 1. Let's say I have 1 power of 3, I get 1. 2 power of 3, I get 8. And 3 power of 3, I get 27. So from here, I can transfer this value to the graph. Okay, x-axis is t, y-axis is y. So I have the x-axis for 1, 2, 3. And this is the y-axis, 10, 20, and 30. So for positive value, when t equal to 1, I have the value 1. The value 1, and for t equal to 2, I have the value of 8. And for t equal to 3, I have the value of 27. So I have the graph I can draw like this. Whereas for negative 1, okay, for value of t equal to negative 1, okay, this is negative 2, this is negative 3. For t equal to negative 1, I have the value of negative 1 too. For t equal to 2, I have negative 8. For t equal to 3, I have negative 27. So I can draw the graph like this. This is t power of 3. Okay, next, let's move to next question, where t power of 3 multiplied with hash t minus 1. Okay, as you know, t minus 1, this means that the unit step function is starting from t equal to 1 to infinity. Okay, 1 to infinity. Okay, let's draw the graph. 1, 2, and 3. This is 10, 20, and 30. Okay, so you already know the t power of 3 graph is just like the answer in your left hand side. But you need to start the graph only at t equal to 1. This means that whatever value before n equal to 1, you no need to do. You just assume it as 0 only. So your graph only starting from t equal to 1. So t equal to 1, you have the value of 1. T equal to 2, you have the value of 8. T equal to 3, you have the value of 27. So you can draw the graph like this. Okay, and it stopped at number 1. And before that, the value is 0. Okay, and this graph goes to infinity. For this question, t minus 1 power of 3 hash t minus 1. If you notice that these both are at t minus 1. So this means that for both fulfill t minus 1, t minus 1, it will move the graph, or we can say that it delay the graph 1 unit to the right hand side. Okay, so to draw the graph, we can do it like this. So 1, 2, 3, 4. For the amplitude 10, 20, and 30. Okay, so initially the graph of t power of 3 is starting from 0, but t minus 1 power of 3 hash t minus 1 both at delay 1 unit. So we move the whole graph 1 unit to the right hand side. So this means that when t equal to 1 is 0, when t equal to 2, you have the value of 1. When t equal to 3, you have the value of 8. And t equal to 4, you have the value of 27. So the graph will be look like this, to infinity. Do you get it? Question G is to sketch the graph of cos t. Okay, before you sketch the graph of cos t, you must know what is the value of cos t. If we substitute the cos 0, it is 1. If we substitute cos equal to 0.5 pi, it is 0. Cos pi equal to minus 1. Cos 1.5 pi, it is 0. And cos 2 pi, it is 1. So the amplitude of cos is 1 only, 1. Okay, so you have you can plot from minus 1 to 1. Okay, so by following the value, we have t from 0 to 2 pi. Okay, so when t equal to 0 is 1, and t equal to 0.5 pi, it is 0, and cos pi is negative 1, and 1.5 pi is 0, and 2 pi is 1. So you can plot the cos graph. Okay, this will complete one cycle. Question hash request to plot the cos t hash t minus pi. So this means that when t minus pi, t is equal to pi. This means that it's starting from pi to infinity. Okay, and we follow the same cos t as obtained from answer in G, just that the graph starting from pi to infinity only. So this is pi, and then this is 2 pi minus 1 to 1. So the graph from pi to infinity. So I'll take this point, and this point. Okay, the front part is 0 because the graph is starting from pi to infinity. For cos t minus pi hash t minus pi, both has t minus pi and t minus pi. This means that the graph delay for pi unit. So let's say this is the pi here. The same graph as obtained in G. Okay, so this is the 1 and you have 0, and this is negative 1, and then you have a 0 again, and you have the 1 again. So the graph will be like this. Okay, do you get it? Thank you for your attention. See you again on next class.